Hi viewers, welcome to this channel. Myself R. Prakash, working as Assistant Professor, Department of Mechanical Engineering in K.S.Rangasamy College of Technology. Today we are going to discuss about basic concepts in thermodynamics. So first, thermodynamic system. So thermodynamic system consists of three things. One is system, boundary and surroundings. Okay. So in this case, so system is the quantity of matter or region chosen for a study. So we have discussed or we study anything. So we have chosen it for a certain space. So that is we consider as a system. Then second thing is surroundings. That surrounding is nothing but the everything outside the system we call it as surrounding. Then third thing, boundary. So boundary is nothing but it's a layer that separates the system and surroundings. It may be a real or imaginary surface. So this is called as boundary. So there is a three thing. One is a system. The system is nothing but it's a quantity of matter or region chosen for a study. So that is a system. Then surrounding is nothing but is everything outside of the system we call it as surrounding. And third thing, boundary. That boundary is nothing but it's a layer separates the system and surroundings. So that is we call it as boundary. Then next thing, there is a three types of system. So one is closed system, open system and isolated system. Now we are going to discuss elaborately in all the systems. The first thing is closed system. So in this thing we are simply considering a piston cylinder arrangement. So this is nothing but this is a cylinder and this is a piston. So in this thing we are simply considering a piston cylinder arrangement. In this one there is a no mass transfer in this system, only the energy transfer will be carried out. So this type of system we call it as generally called as closed system. A system only having a energy transfer, there is no mass transfer. This type of system generally we call it as closed system. So this is simply we call it as controlled mass. Okay. So this type of system we simply call it as controlled mass. So we simply see one simple example. So initially we consider a piston cylinder arrangement having a gas of 2 kg of mass with a 1 meter cube of volume. So this is the initial condition. So after substituting the energy, so that is the heat input to this system, what happens, the gas molecules get expanded, the volume of gas get increased 1 meter cube to 3 meter cube. So due to this process, the mass of the system remains constant, that is 2 kg remains constant. Due to the addition of heat energy to the system, the volume get increased. So the change of system will be taking place. So this type of system we call it as generally called as closed system. So examples like piston cylinder arrangements in compression power stroke in IC engine process. So in IC engine, the compression stroke and power stroke, there is no fuel in or fuel out will be taking place. So what amount of air fuel mixture in the engine cylinder, the process will be taking place. Okay. So in this case, there is a certain energy transfer will be carried out. There is no mass transfer will be carried out. So this is the example for closed system. Then followed by open system. So in this case, both mass transfer as well as energy transfer will be taking place. So this type of system is generally called as control volume. The volume of the system remains constant. Okay. So this type of system is generally called as open system. For certain example, we'll consider as a water heater. So in this thing, so simultaneously the water in and water will be taking place in the water heater. Okay. So in this case, so both energy transfer as well as mass transfer will be carried out. For this particular water heater, so the cold water will be inlet will be carried out here, then followed by the energy heat addition will be taking place. So due to the heat addition process, the water had heated up and the hot water will be leaving from the system. So this is the thing happening in the water heater. So in this case, both heat addition as well as mass transfer will be taking place here. So this is the best example for open system. Some examples like compressor, turbine, nozzle and suction and exhaust stroke in IC engine process is the best suited example for open system. Then next case is isolated system. So in this case, so there is a piston cylinder arrangement. In this one, there is no mass transfer as well as there is no energy transfer will be carried out. So this is the case for isolated system. So this is a practically impossible one, but in this typical example for this is thermal flask. So in this case, the thermal flask we are using for a maintaining the temperature for a certain period of time. For coffee or tea or hot water, we place it in a certain flask for a certain period of time to maintain this heat. Okay, so for this purpose we are using this type of flask. So this is the best suited example for isolated system for a certain period of time only. Okay, so during this period there is no mass transfer as well as energy transfer will be taking place. Okay, so best example is the thermal flask and our universe. So this is the suited example for isolated system. Then the difference between these three systems, that is closed system, open system and isolated system. So in case of closed system, the energy may cross its boundary, but in case of isolated system, there is no energy can cross its boundary. Both open system as well as closed system, the energy may cross its boundary. Okay, so in this case there may be a certain heat addition or heat removal will be taking place in closed system and open system, but there is no heat addition, there is no heat removal will be taking place in isolated system. Then next case, no mass can cross its boundary. Then in case of closed system, there is no mass transfer will be carried out. So only whatever the mass available in this system, that mass will be processed. Okay. But in case of open system, the continuous mass transfer will be taking place. But in case of isolated system, there is no mass transfer will be taking place. The suited example is a piston cylinder arrangement in case of compression stroke and power stroke for closed system. Then open system, that the steady flow devices like compressor, turbine, pump, nozzle, condenser, boiler. In this case, the continuous mass transfer will be taking place. Okay, so this is the suited example for open system. Then followed by isolated system. So thermal flask continuous is the best example for this system. Then next thing is the properties of the system. So first we discussed about a system and what are the types of system, then followed by what are the properties involved in the system. The system, the property is nothing but some of the characteristics of the system, we call it as a property. Some of the familiar properties are the pressure of the system, temperature of the system, volume, density and mass. So these are the some of the characteristics of the system. Okay, so that is we call it as properties. Okay, pressure, temperature, volume, density and mass are the some of the properties of the system. So in this thing, so these properties we generally categorize into two things. One is extensive properties, another one is the intensive properties, right? That what are the properties we call as extensive properties and what are the properties we call as intensive properties depend on, so only one thing, that is the mass of the system. Okay, so once the mass of the system depends on this, that property we call it as extensive properties. What are the properties it is independent of mass, that property we generally call it as intensive properties. Okay, in major cases all all properties will be denoted by certain case letters, that is uppercase or lowercase letters. For example, so mass we may simply mentioned as m. Okay, that is small letter m. But in case of pressure and temperature, we mentioned as P, capital P and capital T for temperature. So this is we simply denote some of the properties. So for this case, most of the uppercase letters are used to denote the extensive properties. So only one expansion, that is mass. So m is the major expansion for this list. Then in case of intensive properties, maximum all the lower letters are used for intensive properties, but with the major expansion for pressure and temperature. So these two things are excluded in this thing. Then some of the examples for extensive properties, mass, volume and momentum. So these are the major example for extensive property, because it's depend on mass, the value gets changed. Okay, so this is the extensive properties. In case of temperature, pressure, density, it's not depend on mass. Okay, so these properties generally we call it as intensive properties. So these properties we can easily known by using a simple one example. So let us consider a system, the system having a certain mass, volume, temperature, pressure and density. Okay, that m represent mass, v represent volume, t represent temperature, p represent pressure and rho represent density. Okay, so there is a certain simple system, the system has a certain properties. Okay, so in these properties, so this is a certain volume, mass, temperature and pressure and density having this system. Okay, so in this one what we are doing is simply we split this system into two equal halves. What it happens, the mass of the system will be simply transferred into half mass plus half mass, that is 1 mass. Then volume will be transferred into half volume plus half volume. Then the temperature remains constant for these two equal halves, right? So in this case, the temperature system may be maintained as 100 degrees Celsius. It may be 100 at this half as well as this half. Like as pressure also they remains same. Like as density also remains same. But in case of mass and volume, it's depend on size. The mass of the system and volume of the system may vary. So what are the properties may vary? That properties we call it as extensive properties. Why vary? It's depend on mass. So in this first step itself, it's clearly mentioned it depend on size or extent of the system. So these properties we generally categorize as extensive properties. Then the temperature, pressure, density. So these properties are it's independent of mass. So these properties we call it as intensive properties. Then specific properties. That specific property is nothing but the extensive properties per unit mass we call it as specific properties. So this is the in few cases we don't know about that certain mass, how much mass will be traveling this system. So at that time we are using a unit mass system. Okay, so in that case we are using that specific properties. Okay, some other examples of specific properties like specific volume, specific enthalpy, specific entropy, and specific total energy, that is specific energy. Okay, so but volume, enthalpy, entropy, and energy we generally categorize as extensive properties, but with respect to unit mass, these properties are we call it as specific properties. That is specific properties is specific volume, specific enthalpy, specific entropy, and specific energy. These things are we called as specific properties. So generally all specific properties are intensive properties. So this is the basic thing. Keep learning and growing. Thanks for watching. Thank you.